Hi, Nafisa.
Hi, Sudu. How are you doing?
I'm good. I'm actually on emergency duty, but I got some
Oh my
time.
God. How
Yeah.
will you manage for 2 hours?
Now, this today we have this correlation, so it'll be done in 45 minutes. So it's
Okay.
correlation will be done. Can you hear me properly?
Yes, I can hear you
Okay,
perfect.
good. That was the main concern. Okay, good.
So, like, you have casualty duty.
No, OBGY.
Okay, then that is good.
Yeah. My so that we are two people, so my friend is covering for me. So,
Okay, that's
so I'll
nice.
just keep my video off because it will save some bandwidth.
Yeah, keep it off. Do you have your laptop there? How will you share
Yes,
the
yes.
screen?
Yeah, I have my laptop. I brought my laptop today.
अरे वाह.
Yeah.
Actually, क्या है कि this week was very busy for many members. So I received
Oh.
emails that we will not be able to join. And I was like, hey, we can't just keep on shifting. Uh, it's better if we record it. And
Yeah, and we can keep more such workshops for any other people who want to join.
yeah, of course, you um, actually the thing is that in our MOU we can keep it that all the workshops that you host, I'll just share on my group, no? So paid,
Yes.
unpaid, any kind. So
Yeah,
our
yeah, that will be good. Then everybody can join in when they have time.
huh.
Yeah.
So like how many months you are saying 1 more month remains for your internship?
Yeah, 1.5. So on May 23rd, it should be yeah, I'm supposed to finish my internship, May 23rd.
Oh, that's nice. So you are from 18 batch, no 17 batch.
17. So yeah,
Okay.
2 more months.
My internship also got over on May
On when?
20. Last year. I'm 16.
Last year. So what are you doing right now?
I'm working as a surgery resident in a medical college.
Acha, so you are a JR1 or what?
Yeah. But I'm non-academic. I didn't give PG exam.
Oh, okay. Interesting.
I can't just, oh my God. It's very difficult. Did you appear for this year's exam?
Yeah, I appeared for NEET PG. Yeah.
So you wanna take a PG? What subject?
I don't know. My rank was sixth. That was not my primary exam. I gave USMLE step one, and I'm
Oh,
going
you wanna
for
go
it.
to US?
Yeah, I want to go to the US for some time at least before coming back. Let's see.
Achha.
I'm not sure how this will play out. So just taking one day at a time. Let's see.
Same, yeah. I have no idea what I'm gonna go. I have to be here for 6 more months so that I can get my documents back. Ruler bond.
Okay. Acha, you are completing your bond, is it?
Yeah. Then I
Acha.
also wanna go and study in some foreign university, but
Hmm.
not like a residency, any masters.
Okay. Got it. That's good. So in research or something like that.
Let's see. No idea.
Yeah.
Anybody who's willing to offer me a full ride, I'll go.
Yeah.
It's
Yeah.
super expensive, yeah. No? Actually, I wanna travel. So anyway, through study, work. So
Yeah. That's a good.
US is actually you'll need a lot of capital to go there.
Yeah, you need a lot of capital and you need to stick around for a long time.
Yeah, exactly. So like after MBBS, it's like 8 to 10 years commitment.
Yeah. Yeah. That's
I'm
right.
just eating Maggie. I
Okay.
didn't
Hi,
have
Vidhi. Is your audio audio working today?
I'm guessing not.
Yeah. Vidhi, I'm going to tell you to do some analysis today. Last time you missed out.
Idhi and Pratik are interns too, no? So same batch as you.
Yes, yes.
Can you hear me now?
Yeah, I can hear you. Great. And Pratik
Great,
is
my
also
mic
joined.
works.
Oh, yeah.
Definitely, I'll screen share it.
Yes. Okay, I think we can start right now. So all those who Nafisa, how many people are going to join? Do you know? Do you have an estimate?
2-3 more people, I'm guessing. But you can begin. They'll.
Okay, let's wait till 5. The 2 more
Okay.
minutes. I think even Pratik's and with these internship might be ending in 1.5 more months.
Yeah.
17 batch, so same as me.
Same, yeah.
Yeah.
How is internship back in KEM? I mean, as hectic as Cyan or
No,
chillax?
I'm not in KM, I'm in Pune right now.
Oh, okay,
Yeah.
okay.
So I'm on ED today, right now. Somebody's
Oh.
covering for me till I take this session. That's why today I'll not switch on the camera.
Okay.
Yeah.
How's the weather there? Is it raining or stuff?
Where?
Yeah, we have rains.
In Mumbai or Pune?
In Vidisha.
What?
I'm asking about you both.
Acha, in Pune it is quite hot right now. Mumbai, I'm guessing, I'm 100% sure it will be hot.
Yeah. Mumbai will always be 4 to 5 degrees more than Pune.
Yeah. And even if it isn't 4 to 5 degrees higher, the humidity will make it
Yeah.
worse.
Oh my god. So humidity is the worst यार. चिपचिपी गर्मी तो लगता है
Yeah.
मेरे को सबसे ठंडी हो रही है. नहा धो के भी
Yeah.
लगता है कि नहीं नहाया है 5 मिनट बाद.
Yeah. Okay, let's start now. I'll share my screen. And all right. So today's session is going to be a short one, a brief one, but it is going to be an important one because we are going to talk about correlation, both parametric and non-parametric correlations. And this will be a good, background for next session, especially for linear regression. So basically what we are trying to do in correlation is very simple. We want to establish an association between two continuous variables. So both of our variables are going to be continuous or numeric, right? And we want to establish associations between two variables. Now, before starting off, I am going to give you an example. So numerical variables, as you may remember, are of two types. So they are either continuous or they are ordinal. So if you remember, continuous or scale variables are variables which may include decimals or which may include, a large number of values between the two endpoints. For example, you have a scale, you have, so if you heard of Oxford knee scores or something like that in orthopedics or any other scores which range, which, have a lot of digits in between. So 0 to 100, 0 to 200, those can be considered as continuous variables or scale variables. But if you have, for example, a numeric rating pain scale score, that is usually, if you remember, from 0 to 10, it can also be from 0 to 100. So that is a good example. So consider, for example, the numeric rating pain scale score. So when the NRS, we take the range between 0 and 10, 0 being the least amount of pain and 10 being the worst pain imaginable. So we can consider that to be an ordinal variable. So it is ordered from 0 to 10 because we only have 11 values, right? From 0 to 10, we only have 11 values. those are very less. So we can, consider it to be ordinal. So 0, 0, 1, 2, 3, and you get an idea about 4 is quite significantly more than 3 because it's just a factor of 1. But NRS can also be from 0 to 100. So in some places consider the NRS to be 0 to 100, or you may see some literature stating NRS to be 0 to 100. So in that case, when it is from 0 to 100, you can consider that to be a scale variable or continuous variable, because if you consider 34 and 35, I mean, subjectively, it might not be too much of a difference. Like you can easily say 34, a patient can easily say they have a 34 rating pain 1 second before, and the next second they might say it's 35. So it's not usually much of a difference. So that is why it is a scale, or you can think about it as a scale variable, and you can think about how it is different than an ordinal variable. That is the main. So when you have so correlation is basically to establish an association between two continuous variables, two numerical variables. Now, if you have one ordinal variable and one scale variable, you might need to use a non-parametric test. So let me give you an example. So parametric correlation is the commonly used Pearson's correlation, and non-parametric correlation is what you might have heard of, Spearman's correlation or Kendall's correlation. So these are the two subtypes of non-parametric correlation. So if any one of your variable or both of your variables are ordinal, they're ordered, then you might need to use non-parametric correlation. So most of the times you need to use non-parametric correlation. The only place you can get away with using parametric correlation in such a case, when you have ordinal variables, is if you have pre-specified the power beforehand. So if you have calculated the sample size before doing the study or running such a correlation, you might the parametric correlation might be a better test. So if you remember from last time, parametric tests usually have more power than non-parametric tests. Non-parametric tests usually give you more false negatives than parametric tests. That is, significant difference might actually exist in your data, but your test is not showing you the significance. That is what we mean by less power in non-parametric tests. So if you have pre-specified your sample size, if you have calculated the power beforehand, then it might be a good choice to just use Pearson's correlation instead of non-parametric. But if you haven't calculated the sample size before, then you might want to use non-parametric tests. So all of this is about ordinal data. Okay, so now let me quickly show you an example, and then today's session will be more of you showing me what you are doing on your screens. So let me quickly go to the regression folder, and we can do this with me. Go to the regression folder and let me open album sales. Open this album sales file. Open the JAS file, not the data file. And let us just first see the data, and then let's read the description. So here we seem to have 4 variables. So adverts, sales, airplay, and attract. All right. So now let's read the description. But before that, you can see that attract is considered to be an ordinal variable by JAS. And if you remember, so what I just said right now, this seems to be from a scale from 1 to 10 or 0 to 10 probably. So this has automatically considered this to be an ordinal variable, as it should. And the rest of these variables, so this is decimal, so clearly it is a scale variable or continuous variable. And both of these, probably range, have a huge range. So these are considered to be continuous variables. So now let's read the description of our data set. So the description. So this fictional data set, album sales, provides factors that may influence album sales. Now, what are these variables? So adverts indicates the amount in thousands of pounds. So this seems to be a UK based data set. So the amount in thousands of pounds spent on promoting the album before release. So adverts indicate the amount of money spent on advertisements. Sales represent the number of copies of each album which were sold. So this is in the number of copies after the release. Airplay seems to be the number of times the songs from any song from the album was played on a national radio station in the week before release. And attract is the attractiveness rating that people found the band's image. Okay, so each row corresponds to a different album or a different band. So they haven't specified what each row means, but presumably it may be different albums of different bands. So that might be what these mean. So now we want to find out the correlation strength between, say, probably advertisements. So advertisements, remember that they are thousands of pounds. So this is, probably 10,000 pounds spent on advertisements before the release of the album. And 330 indicates the number of probably millions of copies sold of the album. So we want to establish the association between adverts and sales. So how strongly associated are they? How strongly correlated are they? Okay. So we want to establish this association. So we want to do correlation analysis. All right. Before that, uh, one might want to do descriptive statistics. So get the get the mean, the median, so on and so forth. But for this example, I am going to skip performing descriptive statistics, and I am straight away going to correlation, because when I ask you guys to share your screens, I want you all to perform the analyses in the correct way. So starting from descriptives. So I won't be sharing that. I will straight away go to correlation. Okay. Oh, and remember, if your data are non-normally distributed, so if they do not follow a standard bell-shaped normal curve, you also might want to consider performing non-parametric tests. So that is why performing descriptive statistics and getting a histogram and seeing the normality of data, performing the Shapiro-Wilk test, if you remember, that is a test for normality, is essential before running any type of parametric analysis. But I'm not going to do all of that. I'm just going to show you how to perform parametric and non-parametric, and then I want you guys to show me how you do the analysis today. So I'm going to go to correlation. And this is a problem with this release of JASP. So this 0.17.1 has some problem. Okay, so that is why a peculiar thing needs to be done, but that will be fixed in the next version. Okay, so basically our hypothesis. So what is our null hypothesis? Now we want to formulate our null hypothesis before running this analysis. So basically the research question is, we want to find out whether there exists an association between sales and adverts. So the null hypothesis in this case will be, there exists no correlation between the amount of pounds spent in advertisements and the number of millions of sales sold, albums, copies sold. So that is our null hypothesis. So the alternate hypothesis will of course be that there exists a significant association or correlation between the number of advertisements and the number of sales. Remember that this does not imply causality. This just indicates association. So if I remember from your PSM lectures, so there are so causality and association are two different things. So causality is when we have definitive evidence that one risk factor or one intervention for certain causes an outcome. Whereas association is that, yes, there is a significant association. Like if you see one thing, you will most likely expect the other thing, but you do not know which causes which, or how both of these are actually temporally related. So temporally means in time. Okay. So correlation will just establish association. We will perform, so regression to some extent establishes causality. All right. prediction. So one variable predicts the other variable, but it's not a hard and fast thing. Correlation will just establish association. So let me put both of these. So we want to see the correlation between advertisements and number of sales. So the number of money spent on advertisement, the money spent on advertisement, and the sales. So are they correlated? Let's find out. Let's put both of these variables into the variables box. And right away we get a Pearson's R correlation coefficient, and we get a p-value stating setting whether this correlation is significant or not. So whether they actually are correlated or not. So the p-value seems to be highly significant. So 10 raised to minus 19. So it is quite the probability is quite low that they are not correlated. So correlation exists, and 0.58 is a strong correlation. So again, if you remember our Cohen's d, so like we have small, medium, and large effect sizes, even Pearson's R has small, medium, and large effect sizes. So what are these small, medium, and large? So 0.2 to 0.4 is 0.1 to 0.3 is indicates a small to medium effect. 0.3 to 0.5 indicates a medium to strong effect, and more than 5 indicates a very strong correlation. So this is more than 0.5. So this indicates that we have a very strong positive correlation. So again, correlation can be positive and negative. Okay. So positive correlation indicates that when one variable increases, the other variable also increases. So here, if you see the Pearson's R, it is positive. It does not have a negative sign. So that means it is a positive correlation. So as the number of advertisements increase, the number of sales also increases. So that is what we mean by positive. If we had a negative correlation, okay, so if we had suppose minus 0.58, so that would mean we had a negative correlation. So that would mean that as the number of advertisements increased, sales would decrease, or vice versa. Sales increase, advertisement decrease. So that is what we mean by negative correlation. Okay. Now, this Pearson's R correlation coefficient ranges from -1 to +1. So -1 means perfect negative correlation. So it is a perfect correlation, and all the points fall in a straight line. Whereas a +1 correlation coefficient indicates again a perfect correlation, and all the points fall on a straight line. Correlation coefficient of 0 means that there is no association, no correlation at all. So the results are very haphazard, and both of these variables are absolutely not correlated with one another. All right. So suppose you have a correlation coefficient of 0.15. So that is close to 0, right? It is neither close to +1, neither close to -1. It is 0.15. So it is a very, and according to Cohen's effect size values, this effect size Pearson's R of 0.15 is small. But if we have a significant p-value, say less than 0.05, that would still mean that even if the correlation is small, even if the association is small, it is still a significant association. So that is what it means. So it doesn't matter if you have a small Pearson's R, if you have a small correlation coefficient. If the p-value is significant, then your correlation is significant. That is what it means. So now let's just find out the nitty-gritties of correlation in JASP. So display pairwise will give you a nice, pairwise display. Okay. And this is especially very useful when you have lots of variables. So if you have lots of variables, this pairwise display will give you a nice row-wise correlation display. So to make this apparent, I'll just plug in all 4 variables, and you can see that all of these correlations are displayed pairwise now. So all of these are now displayed pairwise. So if I remove this display pairwise option, you can see how it is not an efficient use of space, and it does not look quite natural. It looks, but it is, might be easier to interpret. Okay. But I usually prefer this display pairwise option because it takes up less space. Now flag significant correlations, it will flag whatever correlation is significant. So adverse and error. So these two are not correlated. the p-value is also not significant. So that is why it is not flagged. And the legends are given here. Okay. Let me now remove both of these variables just to make it simple. Okay. Confidence intervals will give the confidence interval for this R correlation coefficient. So these range from 0.48 to 0.66. Now remember, if these confidence intervals cross 0, then the correlation coefficient is not significant. You would also expect to see a p-value that is not significant, because 0 is the null value, right? It ranges, the Pearson's R ranges from -1 to +1, and 0 indicates the null value. So if the CI crosses the null value, that means your result is not significant. So if you remember from my first session, that is the interpretation. Now we'll get some nice plots. Okay. We'll get some scatter plots. And this is basically the scatter plot. So this is what you are expecting to see. So a very simple scatter plot. So each point, so this is one album which was sold, and this corresponds to the sales, and this corresponds to the money spent on advertisement. So all of these points represent the coordinates, so to speak, of each album sale, of each album. The densities for variables option will give us nice histograms on corresponding to these variables. So selecting this option will give you histogram. Okay, and here we can automatically see whether the data are normally distributed or not. So sales seem to be normally distributed. This seems to follow the nice normal bell-shaped pattern, but adverts seem to be positively skewed. So if you remember from last session, I explained about positive and negative skew. So positive skew is when the tail, is prolonged on the right side. If the tail is, very prolonged on the left side, that is a negative skew. So this is a positively skewed and non-normal advertisement distribution. Okay. So we might not need to use a non-parametric correlation because it is not normal. So if you want to see the assumptions of parametric correlation, you can of course press this I, show info for this analysis. And you can see these assumptions. Okay. So for Pearson's correlation coefficient, we need to have continuous variables. The data are a random sample. Okay. So the first assumption is met. Of course, both are continuous. Second assumption is, hopefully met, because we haven't created the data and we haven't, entered the data ourselves. So we are assuming that they might be normal, random samples. They follow bivariate normal distribution. Okay, so we can see that this is not normal. So this assumption is violated. And the relationship between the pairs of variables is linear. So that is also an assumption. And this is extremely linear. Okay. So as we would expect, as the number of advertisements increase, the number of sales also increase. So as is evident by the positive Pearson's R. Now, what are the assumptions for non-parametric, Spearman's rho and Kendall's stuff? So what are the assumptions which need to be met? So as I explained, if any one of your variables is ordinal, you need to perform a non-parametric test. Again, the data random sample that should be met. And the last assumption, the relationship between pairs of variables, is monotonic. So basically, one assumption is not met, that this data is normal. And we can also, if we go to assumption checks here, we can perform the Shapiro-Wilk test, this one, for pairwise normality. And we get a significant p-value. Remember that any significant p-value for assumption checks, we mean that that assumption is violated. Remember that. So this p-value is significant. That means this assumption is violated. That means one of both of these variables is non-normal, and we can see that this advertisement is non-normal. So that is very evident. So we need to modify our analysis. Okay, so before performing either of these two, so Spearman's rho, Kendall's tau, so you can perform either of the two. There is no rule about when to perform what test. You can perform either Spearman's or Kendall's for it, no problem. Now the statistics option will give us a nice, in the graph, will give us a nice coefficient right here in the graph itself. So this is helpful when you need to, publish your illustration or your plot in a paper. All of these statistics and, data are available in one plot itself. So it is very efficient use of space and number of plots. Confidence intervals option will give you confidence bands. So yeah, so these are the confidence bands. Okay. And that is all. Those are the most important aspects you need to consider. Now, to address the point of non-normal distribution of data, so this positively skewed data. So we can perform Spearman's rho, but this version of JASP, will give us some. This gave us values without any problem. Usually, what happens is that in this version, we need to refresh the analysis, but this time it was good. So let me just show you how to refresh. We can, go here and select the refresh all. Okay, so if you have this version of JASP and you do not get any values, just go to refresh all by selecting this drop down and you will get the values, no problem. Okay. So even the Spearman's rho coefficient is very significant, and the strength of association is also, similar and quite high. Let me also show you how Kendall's tau looks like. Oh, this is what will be seen. So just need to refresh the analysis and you'll, yeah. So even this is this association is, as you can see, quite low. So this was 0.5 and is 0.4. So that is a drawback. Kendall's tau is usually more conservative than Spearman's rho. So what do I mean by conservative? It is exactly what it sounds like. Kendall's tau is conservative. That means it will usually, show you a lesser degree of association. So that is why I usually don't prefer Kendall's tau. I just use Spearman's rho. So let me deselect Kendall's tau and let's roll with this. And you will also now get a Spearman's rho value in your plot. All right. So this is all about correlation in JASP. So now I want to see what you guys come up with. Let me stop my screen sharing and okay, wait, one chat. What are prediction intervals? So prediction intervals are different than confidence intervals, and these are the intervals which predict the data wholly. So you see that these are very, very, very wide, and this will give you an accurate estimation of the entire population. So that those are prediction intervals. Confidence intervals usually predict our bands from your own data. So there are, statistical formulae used to calculate both of these, but prediction intervals, you won't see prediction intervals that often in any papers. Now let me show you what heat map looks like. So heat map will make sense if we have, more variables. So let me show you what a heat map looks like. So you might know what a heat map looks like, but let me just show you myself. So let's just wait till they load. So basically the heat map will show you. I think it's waiting for all these graphs to be displayed first. And then we'll get a heat map. The heat map will give you pairwise correlation. Yeah, the heat map will give you pairwise correlation coefficients. So these are the correlation coefficients, and you can see all of these very conveniently in one graph itself. And you can visual. So the darker the color, the higher degree of correlation exists. There exists, and the lighter the color, the lower uh, correlation, the lower degree of association, the lower magnitude of association. And of course, the 3 stars or 2 stars or even 1 star indicates that the p-value is significant, less than 0.05. And so 3 stars indicate a p-value of less than 0.001. 2 stars indicate a p-value of less than 0.01. And 1 star indicates a p-value less than 0.05. So if you want to see, it is given here. So these are the legends for the number of stars and what p-values they denote. So basically that's all from my side. Now I am going to stop my screen sharing. And let me ask Vidhi now to share your screen. Open JASP and share your screen. Oh, let me first give
Yeah,
you,
okay.
Yeah, okay, now you can share.
Yeah, can you see my screen?
Yeah, I can see your screen.
Okay.
Oh, Pratik does not have access. Okay, now Vidhi will do everything today.
Okay.
Okay, now okay. So what I wanted to do is go to the three, go to that. Go to open data library, and wait a second. What data do I want? Yeah, I think we can go to regression itself. And let me see. Yeah, go to auction and open the JASP file. Yeah.
Okay.
You'll probably need to share the other tab from Zoom. I can see the first tab still.
Okay. Wait a second. Huh?
Yeah.
Is it visible now?
Yes. Yes. So is there any description? Because this is the first time seeing this data. Go
Wait a
the right.
second.
Yeah. No, the right one. Yeah. Okay. Fine. So this seems to be age bidder. Okay. Let's see. So this data set auction provides a selling price and age of antique clocks and the number of bidders in the auction. Okay. Okay. Now let's see the data. Okay. So let me pose a research question and I want you to generate the hypotheses. So the
Okay.
research question would be to see whether, I think that as the age of an antique clock increases, the, bidding price will also increase. So now I
Okay.
want you to formulate a formal null hypothesis and an alternative hypothesis for just a correlation analysis.
Okay, so my null hypothesis would be there's no correlation between, like an association between the age of the clock and price at which it sells.
Yes. And the two-tailed
Alternate will
alternative.
be as the age
Yeah.
increases, the price of the clock increases, selling price.
No, that is not two-tailed. That is one-tailed.
Okay, so like negative correlation also, you mean?
Yeah, so formulated two-tailed alternative hypothesis.
Okay, so like it is like age is associated with the price will be like that, no?
Yes, so there exists a
Okay.
significant association between the age of
Association
the
between
clock.
the age
Yeah.
and the price.
So what is that association? So one might, probably somebody might assume that, oh, older clocks might sell for lower prices because they are, dirty, and probably so newer clocks might be the in thing, right? So that might also be somebody might think. So we want to, stay safe and we do not want to jump to any conclusions.
Yeah,
So
yeah.
let's just formulate two-tailed hypothesis, and let's just say that there exists an association. Positive, negative, we'll find out. Okay. So I want you to. So this is actually based analysis. I want you to solve
Okay.
these analysis.
1 second. Sorry to disturb.
Yeah.
So two-tailed means it is an open-ended question, right? Like there is
Yeah,
no
two-tailed. Yeah,
positive,
two-tailed.
negative.
Yes. So there can be a negative or a positive association. We don't know. We find out. That is what it is.
Okay. So where there that is why then when we choose that correlated positively or negatively, we just choose correlation.
Yes.
If
Yes.
there is a one-tailed hypothesis, then we choose either they're correlated positively or negative.
Yes. Exactly.
And
And let me.
they'll give you
Yeah.
opposite result, right? Like in one case, if you run positively, it will show a positive p-value,
Yeah, let
and
me
if
show you how that works. So that is an interesting question, and let me show you. So let her run this analysis first. I want you to,
okay, yeah, sure.
remove all of these previous analyses first. Just you close them
Remove like this by
in the
cross. How do
middle
I?
pane. Yeah, go to the middle pane, the middle, pane.
Yeah, yeah.
Yeah, and just cross.
Okay. Okay. Okay.
Yeah.
So we'll do between the age and the price,
Yes.
and we'll see that it is 0.73 Pearson's R.
So what does that mean?
It means it is significant, right? Like
Highly significant.
highly significant, yes.
Yes. So it is highly correlated, and the p-value it is
Hmm.
highly significant. Yes, good.
Yes.
So now do you want to, maybe perform some assumption checks?
Yeah, we can do the Shapiro's.
Do the pairwise.
Yeah, I did the pairwise.
Yeah, no, you did the multivariate normality. Do the pairwise.
Oh,
Multivariate
okay,
is
okay.
for, if you have, that is also fine multivariate because we only have two variables, but do pairwise because it is more systematic to do pairwise.
Okay, okay.
So when does multivariate come into play? You get the same values. If you click both of these multivariate and pairwise, you'll see both of them are the same because you only have two variables. If
Two
you have three
variables, yeah.
variables, then if you have 3 or 4 variables or more variables, then multivariate normality gives us the assumption for whether all of these variables are normal or not. So in just a jiffy, you get the entire data
Mm-hmm.
normal. Okay,
Okay.
so please interpret this p-value for
Okay,
Shapiro.
since the p-value is not significant, I
Yeah.
mean, this will be a normal, like the normal distribution of
Yes,
the
exactly. Correct.
age and price.
Yeah, perfect. Perfect. Okay, so any other assumptions you want to check or you want to,
We can draw the density graph or something like that if we want to see
yes,
it.
that, yeah, let's just visualize that as well. Okay, great.
Mm.
So the age graph looks to be a little skewed, but
Mhm.
the Shapiro-Wilk test does not
Lie.
not lie. So that's fine. So that is, we'll accept that. We'll relax our assumptions and let's say okay, they are normally distributed and let's accept. This
Yeah.
is fine.
Okay.
Okay. So we'll run just a Pearson's R and we won't run a Spearman's rho or a Kendall's.
Okay.
So why don't you select confidence intervals and let's see what these are. Even the one above. Yeah, statistics, that's fine. That's fine. We get. How about the confidence intervals underneath additional options? Underneath the flag significant correlations. The
Yeah.
statistics
Okay.
wala.
Okay. Got it. Got it. Sorry.
You get it here. Yeah, okay.
Hmm.
So 0.5 to 0.86. Right. So that's fine. So it's not very wide, right? So I would
Hmm.
consider probably if it were from 0.2 to 0.9, then that would be very wide.
Yeah.
So these are very narrow, and even in the graph, we can see that the confidence interval band is quite narrow. It's fine.
Hmm.
And the visually also, if we, imagine that the line was not there, if you just saw the scatter of the raw data,
Yeah.
you would immediately know that, okay, so as the age increases, the price also increases. So is this a positive or a negative correlation?
It's a positive correlation.
Right. So as one variable increases, the other also increases.
Hmm.
Okay. So now I want to show you. So now underneath this alternative hypothesis statistic, I wanted to select correlated negatively option here, the
Where
left side,
was, yeah.
negatively. And you'll see that the p-value is not significant now. Go upper,
Yeah.
go upper. Yeah, you see.
1.
And now select correlate positively. You get a significant p-value. Yes.
Yes.
So basically, if you had, constructed an alternative hypothesis which was one-tailed, and you would probably see a non-significant uh, correlation, right? And that would lead you to have false interpretations. So it is, always a good plan to stick to two-tailed alternative hypothesis
Two-tailed.
unless you have definitive evidence that yes, this might be the case, that they are positively correlated. So it is always good to do that. Even okay. Okay, let's leave this topic for our next time. So cool. Is there a reason why this option? No. Yeah. So Pratik, that's what I was thinking about, whether to show you, whether uh, show. Okay, I'll show you. So go to. I wanted to go to another data set. I wanted to open one more data set.
Okay. Wait, I'll just,
T-test now. T-test this time.
okay, t-test. Okay.
And go to the DRA, the one which Vidhi, were you there during the T-test session?
Not there in the start, but I think Pratik, gave me an overview of it.
Yeah. So I think
Hmm.
you joined in when we were discussing
Yeah.
ANOVA. Okay.
Yeah.
So open
No
the
problem. I'll
yeah,
open
just
it.
open the data file now. Oh, this will be a good revision for you then.
Yeah. Can you see it or should I share my new screen?
I think you need to share your new screen. I can't see.
Yeah.
Okay, I can see your screen now. So
Hmm.
let me just give you an overview of what this data set is. So there are two groups here, the treatment group and a control group. So these are students, okay? And the treatment group have been given training for a certain test. The test is called the DRP test. I won't go into the
Okay.
long form because even I don't remember what the long form is. I think it's directed reading power test, okay?
Okay.
So the treatment group were given training before they were administered the test. So consider that solving a marrow Q bank, okay, for NEET. And the control group, they did not, solve any question bank and they just went and gave NEET. So these are the scores for the treatment group, the ones who solved marrow or something. And the control group is those who did not.
Okay.
So now we want to find out whether the scores, differ. So
Okay.
let's perform. So a two-tailed. So now you only formulate a two-tailed alternative hypothesis for this.
Okay. Total will be there is a association with solving the with going through the direct reading power. No,
Yeah,
they are
training.
subjected to.
So yeah, so there is a significant difference in the DRP scores between the two
Okay.
groups.
The
So treatment
groups.
and two
Okay.
groups.
Okay. Got it.
And a null hypothesis will be there is no difference.
No
And
difference.
now, of course, now this is a very obvious thing that okay, those who had solved question banks or those who were given training will obviously score higher, right? So
Yeah.
now why don't you state a one-tailed alternative hypothesis favoring this one?
Okay. So there's a positive association in the group who solves the like positive association between DRP and the group who is undergoing what treatment they are undergoing, the Q bank, right? Is there a name to it?
Yeah. So a better formulation would be that the average scores or average DRP scores are higher in the treatment group than the control group.
Okay, yeah, simple. Huh?
So yeah, that's a very simple statement you can make. And since t-tests are a difference in means, so that is how you formulate an alternative hypothesis for a t-test. So, okay, so now why don't you go to the t-test module and open independent samples t-test. The group variable will go into the grouping variable. Yeah. And the DRP will go into dependent variable. So by default, you can see that if you scroll a little down in the middle pane, the left wala pane, yeah. So if you see the alternative hypothesis K options, by default, JASP always selects the two-tailed alternative hypothesis. And if you see the illustration, they're not equal to. So these already give an idea that of how to interpret a two-tailed and a one-tailed hypothesis, right? So, by default, the two-tailed alternative hypothesis is selected. So group 1 not equal to group 2. So now we are performing our one-tailed alternative hypothesis that the treatment group would have higher average scores. But yeah, so select the group 1 more than group 2. Let's see. Oh, probably the group 1
control is greater. Yeah.
Yeah, the other one. Okay, yeah, this is significant now. So you can see the note as well. For all tests, the alternative hypothesis specifies that the group control is less than group 3. So that is the alternative hypothesis. And the p-value for this hypothesis is significant, 0.0.
Yeah.
And yeah, so that to answer your question, Pratik, it is this option is there in all the modules. So yeah, so the last sessions I overshot my my specified time of 1 hour. That is why I did not explain everything. But today we had ample time to explain these nitty-gritties, and that's why I could explain. So I think this was. I think we'll end this session right now. Does anybody have any questions? Tomorrow we'll be talking about regression, linear and logistic. So tomorrow it will be an interesting session. Because regression, in its essence, regression is a very powerful tool. Because I won't spoil it for you. Join in tomorrow to know the details.
Okay.
How much time would you take tomorrow?
Oh, tomorrow probably it'll take an hour and 5-10 minutes probably.
Okay. Actually, I'd be traveling, so
okay.
I tried to join, but can't promise. But then, of course, I'll have recording. And also about the recording, I don't know formatting math. So
yeah, no. We'll format that ourselves. And we'll share the formatted recordings with you. That is what we'll do.
Yeah. Thank you so much.
Yeah.
Otherwise, my friend would have to do that. Cool.
Yeah. And to answer Parik's question, multiple regression, I mean, if you want, we can take, but I am not sure whether if more people join, then probably I might need to take it a bit slow and just take simple linear regression with one independent variable. But yeah, that is the power of regression. So you multiple regression essentially is an amazing tool. But okay, but no, if there are more people, probably 3 or 4 more people who are novices, I would just take simple linear regression in the beginning. I will, introduce multiple regression, but not delve into the details for tomorrow's session, because tomorrow we'll be talking about linear as well as logistic. So, and logistic regression in particular takes a little bit more time to understand. Linear regression is fine, like you understand that very easily. But logistic,
linear regression, I already know.
Yeah.
From my MBA
Logistic
class.
regression.
So,
Yeah,
एक काम करते हैं ना, इसको अगर लगता है तो linear or logistics you make tomorrow, and the next on that we discussed earlier, make the other workshops and open it for the community, your whole community, like you do, and then you can invite our members. They'll
Yeah.
come and
So I think we can do that. We'll do multiple regression in the next, and we'll split that multiple linear and multiple logistic, because it takes a bit of time to explain the odds ratios, ROC,
exactly.
the model. It's a tedious. It's sort of tedious. So tomorrow, let's keep it simple. I know that Pratik is a bit more advanced, so he might be bored. Today's session might be a little boring for him. We will just correlation. But sorry, Pratik. Sorry to disappoint, but I'll definitely take uh, multiple regression sessions for you.
Pratik will then now teach our other members. Then.
Yeah.
Those
Yes.
who Saurabh वगैरह, they were busy today.
Yeah,
So
Saurabh did not join today. Okay.
yeah, he's the one very enthusiastic person.
Yes, yes, he is.
Yes. Okay, then awesome. Thank you, Sudhaf. And yeah, I had one question. If you have
Yeah.
time, or is your duty calling?
Yeah, we'll discuss tomorrow if it is okay.
Okay. Chalo. Bye.
Okay, then. Thank you, guys.
Have
Thank you,
fun.
Pratik, Vidhi, and
Bye.
Nafis.
Thank you so
Bye-bye.
much.
Bye,
Okay.
guys.
Bye-bye. See you. Yeah.